Hello everyone, and welcome to the shell sort lecture. So in this lecture we'll have an explanation and visualization of shell sort, and in the next lecture we'll have an implementation in Python of shell sort. So let's discuss what the shell sort algorithm actually does. It's pretty similar to the insertion sort algorithm, but it improves on it by breaking up that original list into a number of smaller sublists instead of just that one singular sublist. And the unique way that these sublists are chosen is the real key to shell sort. So instead of breaking the list into sublists of contiguous items, the shell sort uses an increment that we'll call I. It's sometimes called the gap, and it uses that increment I to create a sublist by choosing all items that are I items apart. So let me go ahead and show you a figure of what I mean by that. So if we look at this figure, this list has 9 items. If we use an increment of 3, then there are 3 sublists, and each of which can be sorted by an insertion sort. And after completing these sorts, we get the list shown here, which I'll show you in the next figure, right here. So although this list isn't completely sorted, something really interesting happens. By sorting these sublists, we've moved the items closer to where they actually belong. So let me go ahead and show you what a final insertion sort using increment of 1 looks like. So here in this figure right now we have the sublist 1, 2, and 3 sorted. So notice how there's these 9 items. We have I equals 3, so little sublists, 3 of them, 3 items each. And if we sort the sublists at an increment of 3 and go to the final insertion sort here, and this one is just going to be using an increment of 1, so in other words, just a standard insertion sort. And then you can note that by performing those earlier sublist sorts, we've actually reduced the total number of shifting operations necessary to put the list in its final order. So for this case, we actually only need 4 more shifts to complete the process. 1 shift for 20, 2 shifts for that 31 element, and 1 more shift for 54. And then your entire list has finally been sorted. Now I'm going to show you one more figure here, and we'll actually get to what this figure is actually doing later on in the implementation. But I mentioned earlier that the way in which the increments are chosen is one of the unique features of shell sort. So we'll show this later in our implementation, but what you can actually do is start a first case with n over 2 sublists, with n being the number of items in your list or array, and then on the next pass perform n over 4, and etc., and then eventually a single list is sorted with that basic insertion sort. So right now this shows what the first sublist of the example implementation we're going to do in the next lecture looks like. So don't worry about this too much now. We'll actually cover this later on when we actually implement our shell sort. So now let's go ahead and take a quick look at some visualizations that you can check out. So we're here at the Jupyter Notebook for the implementation of shell sort, and you'll see some resources for review. Go ahead and click the last one, the sorting algorithms, sorting-algorithms.com, and you'll see some shell sort visualizations for you to check out. And then keep in mind, remember here, that the gray values are unsorted, black values have been sorted. Okay, and then here's the pseudocode for the algorithm, and then it shows you the properties as well. So if we just check how this shell sort looks on a random, you'll see that you have multiple sublists occurring here due to the implementation, and eventually at the end they do one final pass as an insertion sort. Alright, so when we talk about implementing this, we will talk about the properties a little more and why shell sort is a little better than just a normal first pass of an insertion sort. Okay, thanks everyone, and I'll see you at the next lecture.